everyone, I'm Liu, and my serial number is 6550757. Today I'm going to make an ENGG955 presentation, and my research topic is future communications technologies aiding smart metering infrastructure. I divide my presentation into 4 parts. First is the introduction part, then literature review part, then research design part, and at last is the summary part. First of all is the introduction part. So when we talk about communications technologies, there are many factors come to my mind, such as 4G, 5G, and Wi-Fi. These technologies can be applied at my mobile phones, but these technologies are too hard and too complicated for a student to learn, so I don't choose them in my presentation. Here I list 3 popular technologies here. The first one is technologies based on conventional energy such as fossil fuels, but it has many limitations. During the process of burning fossil fuels, it will produce some energy loss. Meanwhile, it will have a negative impact on the environment. And for the smart grid, it is considered as one of the most emerging technologies in the world, and I will talk about it later in the presentation. And for energy internet, EI is an efficient way, but it can easily be attacked by hacker or virus. For instance, if the power goes out, the whole system cannot run anymore. All of the 3 technologies are beneficial to the smart metering infrastructures, but for my choice, I choose smart grid. So here is a concept picture of smart grid, and I will explain it to you. The left part of the picture are some stations. You can see it here. The stations provide wind energy, solar energy, nuclear energy, and electric energy for the energy management system here, which lies on the center of the picture. And on the right-hand side are some smart houses and a smart city. The energy management system on the center can receive power from the stations and react and detect them. If the power is high quality, it can transmit to the smart cities here. Because that the power was transmitted directly from the system to the cities, so it has less energy loss than compared with other smart technologies. The saved energy can be used to develop new advanced technologies for smart metering infrastructures, but this technology is not mature now. In a small-scale experiment conducted in Bali, Indonesia, the results show that the efficiency of smart grid is about 70%. But if we want to promote this technology to the whole world, the efficiency should be improved. So my design question is that, can we make use of the scalability to improve the efficiency of smart grid? Here is another picture of smart grid. So what is scalability? Scalability is changing the size of the smart grid. Look at this picture. We can imagine that the smart grid is a real grid, but how can we make it more efficient? We can expand its size to cover more things here. Scalability is a very important way, because if we want to take another actions, such as we want to build more plants here, it will cost us several years or much money on it. But if we expand the smart grid, the expansion will lead to serve more people because it can cover more cities here. And with the expansion of the smart grid, the scalability will make the line stronger, so it can transmit more electricity at a time. So there are many previous works on my area. The first one is from B. Karimi. He defined a data concentrate unit which can reflect the performance of scalability. He also set 3 pyramids. He changed the values of pyramid to 0.1, 0.5, and 1. The pyramids can reflect the scalability and the efficiency at DCUs. Here is his result. As we can see from it, the data efficiency reduced from 5% to 25%. Karimi did well because he only used MATLAB for his simulation, so it is convenient for other researchers to repeat and verify his results. But the disadvantage is that the author has proposed that the simulation can be affected by the temperature and the location, but he ignored them in his later work, and he only used this one as the only sample. So in my design, I want to make more samples. And the second literature is from Hongke Zhang. He designed HIN. HIN is a protocol which supports the scalability. He designed his experiment in a railway line in China. He applied these 4 technologies on the railway line. By testing the download speed, he want to figure out which technology is most efficient. As we can see from the result, he used HIN and 3 other technologies. So HIN, the result is the best. His experiment has an advantage that he applied the theory into the practice, and the disadvantage is here. He only used 1 sample in China. The experiment should be conducted in more areas. So to my experiment, I want to make more samples, and we have known that HIN is a protocol can support scalability, and HIN is the most efficient technology. So we can get the conclusion that scalability can improve the efficiency of smart grid. So here is my design. I divide my design into 2 parts, simulation and experiment. I make use of the Simulink here, the Simulink function of MATLAB, and I designed this. We can change the input of the HIN in the slider game block, and this part is connected to the Hailing board, and we can see the data and the results from the scope block. If the results and data is correct, then the Hailing board can run normally. Then we can apply the data from the Hailing board to the experiment part. I also use HIN protocol. But different to Hongke Zhang's research, I designed 3 groups, 1 in America, 1 in China, and 1 in Australia. Each group has 2 samples. 1 sample uses HIN and 1 sample uses other technology. By comparing the results of 2 samples, if the HIN is better than other technology, then I will compare the whole results of three groups. If all the groups are similar, it says that HIN can improve the efficiency of smart grid. The advantage of my design is I combine simulation and experiment together, so I can make my design more accurate. The disadvantage is that because my experiment is conducted in 3 countries, so it will take more money and time. So in conclusion, smart grid is an efficient way to aid smart metering infrastructure, and and scalability can improve the efficiency of smart grid. This is my reference list. There are all of my presentation. Thanks for watching.